Ionic radii. Ionic radii is very similar to that of atomic radii. Basically, it's the space that the atom, or in this case ion, is likely to take up where the electrons are found. And in general, the trend is that the more positive, the more negative the ion, the larger the radii, and the more positive the ion, the smaller the radii. And this is going back to before the other trends still follow. The other trends are left to right. The atom gets smaller. And from top to bottom, an atom gets larger. So this is from chapter 8. Okay, and so here we have sodium as a neutral atom, and you see here's the electron configuration with an S1. When it becomes a positive, what happens is that this S1 goes away, but you see here that the size of this one versus the size of this one, it becomes smaller. So as it becomes positive, it becomes smaller. Whereas we have a chlorine atom, and here's chlorine, and has an sp5. When I add an electron to make it negative, it becomes an sp6, and the size goes from smaller to larger. So this is what we're looking at. Okay. And this table is from the textbook, and it shows you the different trends. Okay. So if I go across a row, this is the main groups. Okay. If I go across a row, you see here the fact that there's two different things going on. Okay. I'm going from +1 to +2 to +3. What happens to the size? 95, 65, 50. So from here to here, it's smaller. These two are negative. Okay, so I go from -1 to -2, and I get larger in this area here. Okay, so as I go more positive, it gets smaller. As I go more positive, it gets larger. Okay, so that's showing the previous trend. And the other trend is, like I said, the regular trend. Okay, so if I go down a column, so let's pick 1A. As I go down the column, what happens? Okay, so this is from the chapter 8 trend, that as I go down a column, it gets bigger. So it goes from 60 to 95 to 133 to 148 to 169. So as I go down a column, it still gets larger. Okay. All right, so now looking at these questions, it says, which of the following pairs in increasing order of radii? Okay, so I have tellurium and tellurium 2-. Now in the book this says 2+, it's a misprint. It's supposed to be 2-. So I'm going from neutral to 2-, so therefore Te is first, and then Te 2- being negative is the larger. Okay, and B is aluminum versus aluminum 3+. Since I'm going positive here, the positive is the smallest one, and then aluminum is the larger one. Okay. This one says arrange the following in increasing ionic radii. I have I-, so I'm going to circle the neutrals. I have Cs+, and I have Te 2-, so this one's got it correct in the book. Okay, so there are my 3 atoms. Okay, now this one is 53, but with the negative is 54 electrons. This one is 55 minus 1 electron is also 54 electrons. And Te is 52 with 2 more electrons is also 54 electrons. All right, and so this is defined on the next slide, but this is an isoelectric series, meaning that different elements have the same number of electrons. So this is an isoelectric circuit. So basically, since they're all isoelectric, I'm going to go with the positive, which is going to be Cs. It's going to be my smallest one. I have then 1- and 2-, so the 1- is next, I-, and then Te2 minus is my largest one. Okay. And so here's the definition of the isoelectric series: two or more elements having the same number of electrons. So the example that it gives me here is these are the neutrals up here. So these are neutral. Okay, so oxygen is an sp4. Fluorine is an p5. Neon is a p6. Sodium is a 3s1, and magnesium is an s2. So when I add 2 electrons to this, it becomes p6. When I add 1 electron to this, it becomes a p6. This is already a p6. I take sodium plus, so I take 1 electron away, it becomes 1 p6. And magnesium 2 plus, take 2 electrons away, is a p6. So all these species have 10 electrons with 1s2, 2s2, tp6, or have 10 electrons. Okay, and that is the end of this section.